All right, hi everyone. Welcome to FM, Bluetooth, and Wi-Fi Oh My. I'm Aaron. Slight about me, but this takes too long and we need all the time we can get. So what we're going to be doing today, we're going to be talking about, it's really nothing new. All of these things are already out there, but we're trying to combine them into a talk about RF in general. So we're going to be basically looking for things that are flying around in the air all up around us, but we're not going to try to decode them today because, well, we could spend an hour trying to decode a garage door opener, and at the end of the hour, you could decode one garage door opener. So that wouldn't be very fun, right? But if you're interested in decoding stuff, there's some software packages out there that when you've recorded your signal, you can use to help you go ahead and start your decoding. And in-spectrum, D-spectrum, wave converter, and Audacity are some of the ones that you would want to look at. So why do we want to talk about radio? Well, basically, our organizations and ourselves and anybody that you're contracted to work for has radio all around them all the time. I'm sure right now you've got your smartphone in your pocket or in your hand and you're on Twitter, right? And it's like, that thing has at least 3 or 4 different radios in it. It's got GPS, it's got its cellular radio, it's got Bluetooth, it's got Wi-Fi, and we're carrying these around with us all the time. Organizations are deploying things inside of the organization that have RF in them, and sometimes we're not even aware of it, and we don't even know what's going over it and how it's connected to the rest of our stuff. And the perimeter controls that we've established for other things in our environment really don't mean anything to radio frequencies because they just pass right through walls and us and move on to doing whatever it is they're going to do. And so we should at the very least understand what it is we're broadcasting so that we can help secure that. And we hear all things about the Internet of Things. Well, it's more like the Internet of broken things or the Internet of why we can't have nice things. Radio is a huge component of that. So we're going to start with some really generic terminology, and we're going to keep that terminology generic. Decibels, which we'll talk about a little bit. Basically, for this is a measure of power, and that that measurement is typically in relation to something else. So decibels by itself can be used to measure anything. Like I could say, I'm afraid of clowns, but Dave Kennedy is like afraid of clowns 4 times more than I am. And in decibels, that would be Dave Kennedy is 8 dB more afraid of clowns than I am. Modulation, that's basically creating a difference on your carrier signal to convey information. FM, we're all already familiar with. We listen to it in our cars, but that's modulation of the frequency. AM, same thing, but modulation of the amplitude. And spread spectrum technologies or frequency hopping, that's data that's transmitted across a variety of different frequencies based upon some sort of domain like time or something like that. So we're going to try to start off really simple. Everybody knows Wi-Fi, right? How many people here who have scanned for and cracked Wi-Fi? Right, so we're going to move through this really fast, but we want to start with something really, really familiar. Now, if you're looking to do Wi-Fi, you're going to need a card that's packet injection capable, so I think we all know that TP-Links and Alphas are where we typically go for that. And then your software package, Aircrack Suite is really great. You can do a little bit of stuff with the IW tools that comes in with Linux, and basically you're going to be using Airmon and Kah. What do you got? I'm going to go with Zima there. Thanks. Refreshing. So yeah, so you can use some of the built-in tools, or you can install the Aircrack Suite to do that stuff. So instead of, we're going to try to do most of this stuff with just straight out live demos, because we've got sort of a powered USB hub and hedgehog mode here. So if you're looking, you go, I want to see what cards I have. You run IW config, and the new naming standards for cards are really terrible. So then you see that, but if you want to scan for devices or access points without the Aircrack Suite, you can use the IW tools. You say IW, the device, the name of the card, and then you just tell it to scan, and then it basically dumps a whole bunch of information about the access points that it sees around it. So, tons of information. What's that? Yes, I can. Have you tried squinting? All right, is that readable? A little bigger? All right, let's go a little bigger. All right, so as you can see, you see tons of information about what the capabilities of the access point are, down to what sorts of encryptions it's using, what its power levels are, what its supported information rates are. It's great information, but it's a little bit hard to parse, but it definitely tells you what the equipment is capable of. Making it a little bit easier to parse, you would use, not capital letters, you'd take your card and you move it into monitor mode, and you can do that with the IW config command. So we'll take a look. You see that your network driver or your network card is there. You say start, and you give it that horrible card name. And we'll look one more time just to make sure, and it's changed it to WLAN 0 Mon. Now, then you do arrow dump, so you're going to take that, and you're going to specify your interface. You wait, and all of a sudden you start to see access points. Now, you see some of these ones that say is like length 1 and stuff like that. Those are typically the hidden SSIDs, which don't hide your stuff very long because every time you have a client that needs to join it, they send out a probe. So what I'd like you to do right this moment is take your phones out. And if you know where the MAC address section of your phone is, go look at the MAC address section of your phone. And the reason I'm telling you to do this is because a little later we're going to talk about Bluetooth as well. And you might notice that the MAC address, especially with phones that have system on chip stuff for that sort of thing, that the MAC addresses are within one of each other. So there's going to be an easy association between the MAC address of your Bluetooth and the MAC address of your Wi-Fi. You just have to look for that shift of 1. So we'll go ahead and stop this. Go flip back to our talk. If it will let me. There we go. So we've already done that. We've seen the IW scan. We've seen Airmon NG. We've seen arrow dump, and we don't need to watch the video because we've seen the demo. So we're all pretty familiar with Wi-Fi, so we can zip through that pretty quick. Now, FM radio. We're all used to listening to FM radio. We've probably all had walkie-talkies or maybe some of those bubble pack radios that you get from Walmart. Who's had a bubble pack FRS radio from Walmart? That's right. You got to have one of those. So basically, FM radio works by having a carrier wave. You modulate the carrier wave, and when the receiver gets it, you have something that comes in looking sort of like this stuff down here at the bottom. The receiver takes that, basically says, I'm expecting this particular carrier wave, subtracts that information, mixes it, turns it into sound on your radio or data, depending upon what it is you're actually doing. And we talk about FM radio because inside of organizations, if you're a security person or say you're a pen tester, FM radio is used a lot in larger organizations, and it's almost exclusively used by the physical security folks as well as the maintenance folks. And it's really kind of fun to listen to some of those people because they tell you a lot about the organization. You learn a lot of names. They tend to forget that they're actually on a shared non-private medium sometimes, and you can learn some fun details about their personal lives and how they interrelate with some of their coworkers too. So it's kind of fun to listen to them, but you can pick up a lot of information about what it is you as a defender are leaking out to the rest of the world, or as an attacker, you can figure out things like what are people's names, and hey, when you hear somebody call in and say, I can't get such and such printer to work, we need to call out to our maintenance vendor. Well, guess what you just became? The maintenance vendor. And you know exactly what printer isn't working and what room it's in, so why would you not be the maintenance vendor? There are lots of technologies in FM. Aside from just the standard stuff, you've got narrow frequency mode, you've got wide frequency mode, and FM is stuff you typically see for handheld communication. The wideband stuff is basically used for music. GMRS and FRS, that's the general mobile radio system and family radio system, the bubble pack radios. And then trunk digital and analog, so it's just different takes on that. Trunk controls frequencies from a control channel, makes it more efficient. And maybe you don't know this, but radio licenses are actually public information. So when a company goes out, or yourself go out and get an amateur radio license, the FCC requires that you fill out a form inside of what they call their ULS system. And there are several online databases that you can query for this. My favorite is actually the radio reference database, because they've got tons of stuff in there. And I also like to click on states, because that's a lot of fun. But you can start out with looking at your databases. You can say, I want to look at Texas. Inside of Texas, they will actually divide that down by county. Once you've looked at it by county, you can select some of the metro areas inside of that county. And then once you're down into that sort of metro area, they start giving you a list of all of the registered businesses, because if you look across the top, you'll see the red things are things that I don't care about for this particular search. And it's only showing me actual FCC business licenses. So if you've got a target or you're defending somebody, you can go out to the radio reference database, or you can go to the ULS, and you can actually query the radio licenses that they have. And inside here, they tell you what their call sign is, they tell you what the frequency is, and if you clicked on the actual call sign, then it actually brings up a map and shows you exactly where they are. All fantastic information. So I kind of picked on Hewlett-Packard just because they were there. And you see a lot of the business stuff is typically in the 400 megahertz section. We don't really need the videos. But if you're going to audit FM, some of the tools that you're looking at are scanners, wideband amateur radio transceivers, software-defined radio, and basically as we go through this talk, software-defined radio can be used to do just about everything that there is purpose hardware built for. You just have to spend time building your own GNU radio flow graph and doing the decoding and all of that fun stuff. So at some point you need to figure out what's the trade-off between buying purpose-built hardware and building stuff inside of GNU radio. And then you listen to it, decode it, and you can actually perform denial of service pretty easily against FM radios. You send basically twice the power to the receiver, and that captures the receiver, and nobody can speak to it from then on, as long as your power stays higher. So if you're looking at scanners, what you want to look for, lots of stuff is trunked and lots of stuff is digital these days. So you're going to want to look at something that has both analog and digital modes. NXDN, which is like NextEdge from Kenwood, DMR, which is usually represented as like Turbo from Motorola. So you want that capability. And then the Project 25 Phase 1 and 2, which is part of the trunked radio protocols. And then you want a discriminator tap, because at some point you're going to spend several $100s on this hardware device to do different radio protocols. And 3 or 4 years down the line, somebody's going to come up with a new protocol that your scanner doesn't do. It's nice to have a discriminator tap, because that takes the raw output that the radio receives. You can line it into your computer, and then you can use your general purpose CPU on your computer to decode that protocol. That way you don't necessarily have to go back out and spend $500 or $600 on another scanner. Wideband amateur radio transceivers. Who has one of the Baofeng UVR5s? Right, those radios are great. If they break, you don't care. If you lose it, you don't care. It's like $35, right? It's not like having a Yaesu for like $350, $400. But what you're looking for really depends upon what you want to do. You're a little more limited when you go to this, because most of the time you're not looking at a receiver that's DMR capable or NXDN capable, but there are some DMR analog radios out there. Lots of them only do specific amateur radio type digital modes, so you won't see some of the commercial stuff. And don't transmit without licensing, right? Because that's technically illegal, and there are amateur radio folks who will come after you because they think it's fun to go do Vox hunts and get people reported to the FCC. So get an amateur radio license. It's really easy, and it also enables you to study a bunch of the stuff and transmit into the higher frequencies where all of the cool IoT things go on. And software-defined radios, you can literally start with software-defined radios for about $25. This is one of the RTL dongles that you see tons of information about. It's actually terrestrial digital television adapter that they found out that you could modify to change the receive frequencies, and it had a way higher receive band than what it was limited to by its original software. So one little driver change, and you've got a software-defined radio for $25. And then you can move up from there. If you want to transmit, you can start looking at something like Lime SDRs, Hack RFs. Those run about $350, and the higher up the spectrum you get, you start getting full duplex and FPGAs and more transmit power and the ability to do all sorts of cool things. But you can start with Hack RFs and $20 radios. So now and we'll just do a simple demo. We're going to use the Windows side for this. SDR Sharp is a really great program. We'd have used GNU Radio, but it stutters on the surface, and so we're not going to do that. But simply, up here you see that I've got the RTL SDR. I'm actually tuned for FM. Maybe we'll turn the volume up, and all of a sudden you're decoding FM radio on your PC from a tiny little device and a tiny little antenna. It's just taking that signal, pumping it into your computer, and your computer's doing all the decoding work instead of having a hardware radio to do it for you. We're going to take a moment and talk about pagers. I know you're all thinking, like, pagers? What the hell? Seriously, pagers are actually still used. Does anybody work for a hospital or a medical care provider? So it's like pagers are basically ancient computer system alarm and monitoring systems. They are some ICS SCADA stuff that's been sitting around, drug dealers, and like doctors. So if you work for a medical provider, decoding pagers is really, really easy. And I am not a lawyer. I did not stay at a Holiday Inn Express, and I did not play one on television. So it comes dangerously close to the territory of illegal wiretapping. So if you're going to do this, maybe you should talk with some sort of counsel first, or you can just go out on YouTube and watch all of the people that have been doing it. And I don't think anybody's been arrested yet, but don't take that as your own personal risk, right? If you happen to see what's going on in pagers, it's tons of information out of the medical community. They'll be talking about a patient and where they're going to send that patient and what tests they're going to get. And sometimes they send back really brief test results, and they'll say, patient such and such, these are the numbers, right? It's like, this is like a giant HIPAA violation, just a sieve of information floating out into the atmosphere. And auditing pagers is really, really easy. You need this $20 SDR dongle. You need a computer, which I assume you already have because you bought the dongle. SDR Sharp, PDW, both free. And if you don't do stereo mixing, which is something that allows you to take program input or audio input and channel it into another actual program as well as your speakers, then you need something that's called virtual audio cable. You can get that for free as well. You pipe that audio into the decoder, tune into that band, and it starts decoding paging for you. Simple little picture that I took from the RTL SDR folks, who've got a great tutorial on how to do this. And you can see it's decoded stuff, and they've blanked out names, and actually some of this would have been considered medical information, right? Mitigation strategies. Radios today are way, way easier to configure and way, way easier to use with encryption. Encryption today is like a checkbox on the radio configuration software. I encourage you to use encryption. Take your radios, upgrade them, get encryption, or realize that you need to actually have good radio discipline and maybe not talk about things which could be considered sensitive. Good lesson to try to take to people, right? Pagers, just replace those with some sort of secure messaging solution, because a pager is not a secure messaging solution, especially if you're sending out people's personal health information over it. So Bluetooth is great, right? We use Bluetooth on our watches in the low energy format. We've got Bluetooth headsets. We've got Bluetooth speakers. It's all over the place. And it's nice because, Bluetooth in its infancy was just terribly tragic to do terrible things too. It was really, really easy. And they've made it much harder with the exception of like Blueborn, right? But its frequency ranges is in the ISM bands, and the ISM bands are the industrial, scientific, and medical bands. And these are unlicensed bands, which you can put devices in, and they have to accept interference from the primary users, which are, of course, the folks in the ISM. And their frequency is in that 2.4 gigahertz frequency, which is like the cesspool of wireless, right? Because like everything works at 2.4 because it's license free. Versions are from 1 to 5, and we talked about a little bit about Bluetooth Low Energy. They've sort of been trying to rebrand that as Bluetooth Smart. The downside, now whereas Bluetooth has been getting steadily more secure, Bluetooth Low Energy has almost no security to it. And we won't pick on any of the Bluetooth Low Energy devices that we find, but you can use GAP tool, which is the type of profiles that Bluetooth Low Energy devices have, and connect to those devices, read out the UUIDs, read out the handles, figure out what's readable and writable, and you can actually start writing data to Bluetooth Low Energy devices around you with various hilarious effects, like some of them will come up as pairing requests. There's a guy called Evil Socket who was playing with his Bluetooth Low Energy enabled Vapor and was able to reset the temperature on it to something like 5,000 degrees. Now, he didn't try it because, you know, expensive Vapor and God only knows what it would have done. But yeah, the Bluetooth Low Energy as a standard right now, as it's implemented, it allows you to do a lot of things that maybe you shouldn't be able to do to a device that's like hanging out on your wrist most of the day. Data rates are anywhere between 1 and 50 megabits, and depending upon the type of device you have is basically how far your range can go. Now, the easiest way to start is your computer almost certainly has Bluetooth built into it, and you can use that interface to actually discover devices. Now, it's not like, you know, it was 15 years ago where everything was in discoverable mode by default. These days, most devices aren't in discoverable mode, and that's really good. But if you want to see things from further distances and you want more capability to talk to Bluetooth Low Energy devices, Sena UD100s are about $40. They're a class 1 device, and they're Bluetooth 4, so they are compatible with Bluetooth Smart / Bluetooth Low Energy. But if you want to find something that's not discoverable, that's a little more difficult, and you need, again, you can use an SDR, but Michael Osman, Great Scott Gadgets, has something called a Ubertooth 1. Who's got a Ubertooth 1? Great, they're great little tools, right? The first thing you probably want to do is hit their GitHub and get the software updates for it, because the new software does a lot more and cooler things. So what does this get you? This gets you the ability to actually promiscuously sniff the Bluetooth traffic that's flying through the air, even if the devices aren't discoverable. Kali Linux is a good choice. You know, they come out, they already have a Ubertooth client installed on them. And then the next thing you're going to notice is that I've got these things that sort of look like MAC addresses, but they're really, really short. And that's because Bluetooth devices don't address each other by the complete MAC address in what's called the PicoNet. Inside the PicoNet, they use this little area that's labeled LAP, which is the lower address protocol. And then there are two other things, which is the upper address protocol and the NAP, which is sort of the non-significant address. And they typically don't use that portion to communicate with each other much at all. So if you want to find what those are, you run Ubertooth RX. And we won't do this because I've actually got a captured LAP in the slides, and sometimes it can take a while to actually capture upper address portion. So you can see down this column, it says LAP. There are a whole bunch of addresses there, so obviously there's a decent amount of traffic going on. You can keep looking around by actually specifying that LAP with the -L. And in here, you know, it found the upper address portion in 3 packets. That's not usually how fast it goes, so that's why we're not doing it. But once you've found that, you can specify both of those, right? So now you've got the LAP, you've got the UAP, and if you want to know what the full MAC address is, your only real option probably is to brute force it by using the OUI.txt file that you can download from the IEEE and see if you can connect that way. Or you might be able to just prepend it with a couple of zeros that fill out the rest of it, because sometimes that works as well. There's a caveat to this, though, that most devices these days, if you don't already have a trusted connection and the device is in discoverable mode, lots of devices these days will just refuse to speak back to you. So it'll get your connection request, but it will just not talk back to you. So you can send data to it, which is how I expect that Blueborn is working, but data is not actually coming back to you. And once you have that, you can also then actually follow and capture the distinct traffic between one device and another in the Bluetooth network. Most of the time that information is actually encrypted. And if you want to crack that encryption, your best bet was to have captured the pairing in the first place so that you have the actual PIN number that was used to set it up. This happens to be some traffic that was between my phone and my wireless headset. But I haven't gotten to the point where I'm able to decrypt that and actually rebuild the conversation out of it yet. The new way that you can look for things is Pony Express, Blue Hydra. It's great stuff. I think Zero Chaos is one of the authors, and you'll see him walking around here. Now, did everybody go out and actually look at their MAC addresses? So here we're just going to run Blue Hydra. And this uses both the Cena UD100 that's sitting here, as well as the Ubertooth that's sitting there. And you can see there's a ton of Bluetooth devices. Now, down that column that says version, anything that says BTLE is obviously Bluetooth Low Energy. Anything that doesn't is actually the Bluetooth device using one of the Bluetooth protocols that is somewhere between 1 and 5, and that device is sitting there broadcasting and is actually discoverable. So thank you for that, right? Is Quadling in here? He must be nearby. That's Quadling. So, like we were talking about just a little bit earlier, if you have the one of the MAC addresses, there's a good chance it would help if I had it typed out right. It could be dangerous. All right, so this is sitting here watching every client probe coming out across the wireless network. And over here on this side, we have all the folks who have Bluetooth enabled. And you can see that sometimes you get names for things, which is really, really nice, because then you might have an idea of who that phone or device actually belongs to. And then over here, you can look and actually associate that person's Bluetooth device with that person's Wi-Fi device and all of the Wi-Fi networks that they connect to. So now you know a whole bunch of information about them that they wouldn't necessarily know as just being broadcast over there all the time, right? It's great for like identifying targets and environments, or following people around in the strictly legal non-stalker way. So that's why you should have most of your wireless protocols turned off, right? Is there what? Delete the history? So if you're talking about the wireless probes, you'd probably just want to go and delete those networks from something that your computer remembers or your phone remembers. Because a lot of times you can go look and it'll say, I know of these particular networks. Android, you can like basically hold it and say then forget, and then it won't try to probe for that network anymore. That's my suggestion for that one. So that's some great Bluetooth stuff. And you can do this, we'll go ahead and do that too. You can do this without these tools. It's just a little messier. HCI tool, which comes with most Linux devices. We'll look and see that there's the HCI 0 adapter. So since I only have one, I'm not going to bother specifying it. and then say HCI tool, and we're just going to say scan. And then it's basically going to sit there and listen and try to send out beacons and see if it can find anybody who's actually in discoverable mode. Oh, thanks, somebody. A lot of times you don't get any information back from this scan because most devices have actually protected themselves, but today we get a few of them, right? And then it's got its corollary for Bluetooth low energy, is HCI low energy scan. Now this one just loops on through, it doesn't actually stop. So if you want to stop it, you have to stop it yourself. So also if you try to use like say timeout on this so that it stops after a couple of seconds, I have found that the device stays locked and you have to issue a reset command to the HCI device. So if you start doing this sort of stuff, keep in mind that you have to either hit Control-C, and that frees the device up really well, but the way timeout kills the process keeps the device locked, and you have to issue a reset command afterwards. And then a second tip, this guy, the Cena UD100, has a rewritable MAC address. And it doesn't rewrite in the same way that software, like your Ethernet cards do, because that's all software. It turns out that this guy, when you issue a MAC address rewrite command to it so that you can spoof another device, it actually writes it right onto the device. So if you care about having the original MAC address on your Cena UD100, make a note of it. Unlike myself, I have no idea what the MAC address was. So now it's like permanently one of my Bluetooth keyboards. That's what it goes back to. So that I actually know what its MAC address is all the time. Helpful hint, things that I wish I knew like 5 minutes after it happened. All right, and then the last network we're going to cover is sort of the 802.15.4 network. So just like wireless is an 802.11 network, 802.15.4, one of the biggest players in here is Zigbee, but there are other players. Z-Wave is an 802.15.4 network. The Atmel Lightweight Mesh Protocol is an 802.15.4 network. And it also, surprise, surprise, operates in the 2.4 gigahertz frequency, right? In the USA, there's actually a 915 megahertz Zigbee as well, but I haven't seen a ton of that. Most vendors take the easy way out, right? Everybody can use 2.4, so we're going to make 2.4. Now, why do we care about Zigbee? Zigbee's used, and 802.15.4 networks in general are used for a lot of automation stuff. And that means fire suppression systems, alarms, HVACs, lighting systems. The biggest lighting system that you can think of on the consumer market that uses this is like the Hue lights. But GE's got some and Cree's got some as well. And some of them are interoperable and Wink hubs and stuff like that. In fact, if you want to study some of this stuff, get a Wink hub because it's got a Lutron radio, it's got a Z-Wave radio, it's got a Bluetooth radio, it's got a Zigbee radio. Well worth the $35 for a Wink 1 on Amazon. So Zigbee is typically a mesh network. But it can also be used as a tree or a star, but its most popular implementation is as a mesh network. And this is because Zigbee requires a coordinator, and that coordinator is what tells everybody else what to do. So that's what sends out the command to turn on or turn off a light. Now, in some instances, you could have lights which are way further away from your coordinator than the coordinator can actually reach. So a Zigbee device can act as an actual router, and it says this packet isn't meant for me, but I'm going to broadcast it out to the rest of my friends who can get it, and they're going to broadcast it out to the rest of their friends until the device that actually was meant to receive it receives it, and then it sends back an acknowledgement. I think it's something like 15 hops that a Zigbee packet can move through, so it's not too bad. Zigbee can utilize encryption, but in practice, especially in the lighting space, it appears that they almost never use the encryption, which makes it so that you can do all sorts of fun attacks against Zigbee, like injection and replay. Now, there are two ways to configure the keys in Zigbee. That's with a pre-shared key, which means that before a device goes out, you actually have to write it to the device, and then you ship it out. Now, limited flash writes and things like that, and just simply saying, all right, well, I've changed my network key. Now I have to pull in every single device that's on my mesh network back in. That's not really very, very feasible. So it supports another version of doing this, and that's the network exchange key. Now, just like you would think, you plug in your device, you turn it on, it goes out. Well, actually, the coordinator goes out and it says, I found a device. Here's how you join. And it hands it the network key, your encryption key, in plain text. It's good times, right? So how do you find Zigbee? There are a lot of ways to do it. You can do it with software-defined radios. But I like the Raven USB sticks for a couple of different reasons. One of them is because it's a system on a chip, it's just quicker. And two, you get the bonus of getting the built-in Atmel lightweight mesh protocol because it's an Atmel chip. You can get 2 sticks. If you leave them with the default Atmel stuff, you can basically listen. In order to actually send in traffic, you're going to have to change the firmware. Now, each of these Atmel sticks costs about $50. It's not too terribly expensive. If you get 2, you can transmit and receive at the same time. And in order to change the firmware to the Killer Bee firmware so that you get some attack platform, it takes about another $100 in equipment to actually write the firmware. So you can audit, copy, and replay with Killer Bee. This was from the Riverloop Sec people. And it's a lot of fun. Let's go to exclusive mode. So just to find out what devices you have, you just type ZBID. It comes back and it tells me I've got 2 different Killer Bees, and then you can specify your devices. Now I'm only going to use 1, so it doesn't really matter. But then, obviously, the first thing you'd want to do is figure out what's actually happening around you, right? So we'll add the -V flag to this so that we can actually see it hopping through the channels. Otherwise, it's just kind of silent, does nothing. So send a probe to 11, send a probe to 12. We're going to have a spoiler here. We're not going to find anything till 26. And 26 isn't actually going to be Zigbee. 26 is actually going to be the hotel running lightweight mesh protocol. I've captured packets from a few hotels now. I haven't had any chance to do any studying. But we'll fire this into Wireshark here in a minute when it comes back. And now we should see a ton of stuff come back. Oh, it didn't happen. So far they're going good. If this is the only thing that goes wrong, I'm going to be really happy. So we'll speed it up a little bit, see if it comes back with anything. Nope. All right, well, I know it's there, so that's all that matters. So ZB Wireshark, and then you specify the channel. The -F says, give me some frames 2. This is going to be really hard for everybody to see. Oh, maybe I can't hear it in the conference room. All right, well, it's out there, trust me. So here's what we're going to do. All right, so captured earlier out in the lobby. Can I zoom in this? Yeah. So you can see here, it actually identifies itself. And it looks like everyone I've seen so far has encrypted data. So they actually implement encryption. I have no idea what the hotels are using it for, but some choices might be door locks and lights and HVAC systems. It would really take being able to tear this apart and actually look at it. But there's a wide variety because it's an automation protocol, right? So So far, I'm 3 for 3 hotels that I've been in since I discovered it at the Flamingo in Vegas that actually have lightweight mesh protocol running. Interesting to know that it exists. So we weren't able to find the network, but we know it's there. And now we want to demonstrate the replayability. This is like the eclipse. Don't stare directly into the bulb. It's like the path of totality now. Now we'll put it out here. So I have a packet capture from my wink to this Cree bulb. Sorry, guy. And it's really easy to actually replay it. So go into the directory where it is, and you just say, I want to replay, and I want to use this particular channel. And you had to have found the device anyway. It's unfortunate. Well, look, we'll see. Right, I've got to tell it to actually read the packet file. So now you're sitting here and the bulb's on. There's no hub to control it, and I've replayed the packets, the bulb's off. Bulb's back on. So this is what happens when you don't implement good encryption inside of your protocols, right? Now there's a little bit of replay protection inside of Zigbee, but there's not a ton of replay protection inside of Zigbee. So when this got done, I could immediately replay this and this wouldn't happen again. But if I did this repeatedly for 4 or 5 minutes, I would have changed the counters on the bulb. But I think the value is up to about 255 different values. When that cycles back over, this replay attack works again. It's good times. Is the bulb off or on? Yeah. So, I should have told everybody to bring Eclipse glasses. Sorry about that. All right, so that's us finding it. And this is what it looks like when it actually returns information. So across here, you can see that you get the PAN ID, which is the actual ID of the network. You can see what the source is. A lot of times you'll get replies back from a couple of devices on the network as well as the coordinator, so you'll have to spend some time in Wireshark figuring out who the coordinator of the device is. And then it tells you what the profile and version of Zigbee is, as well as what channel it operates on. And basically, once you know what channel it operates on, you can begin just sitting on that particular channel and pulling in packets and studying them. Wireshark can actually help you figure out what things are, because Wireshark is helpful like that. As you dig down into the packets, you can see as you come down to this thing that says extended source down here, it's identified itself as part of the Philips lighting system. This doesn't happen for everything, but I have to imagine out there someplace there's another thing. So that's all I've got. Thank you for attending. I appreciate it. Does anybody have any questions? Yes, sir. I'm pretty certain it is, but that's a little further than I've dug into real Bluetooth, and now because real Bluetooth is harder right now, and Bluetooth low energy is so easy that I'm digging into that more often. No, the bandwidth on one of the SDRs is about 2 megahertz, and the entire Bluetooth spectrum is, 500 megahertz or something like that. So you need like a whole bank of them, which you could totally do in GNU radio. You could define multiple input sources, Right, yeah. Or you could buy a whole bunch of hack RFs, which are about 8 megahertz worth of space, and I'm not, what's that? 20, okay, so 20 megahertz worth of space. So yeah, you get about 20 of those and you get most of it. No, as an amateur radio licensee on the ham bands, encryption is not allowed. It just depends upon what the license class happens to be and what frequencies you're on. Fine, we saw you out in the hallway. I totally didn't.